Hello there, and welcome to the Sleepy Space Channel. The number of galaxies in the universe is not a settled fact. It is a figure that keeps moving, and within living memory, it has climbed more than tenfold, from a confident 100 billion to no fewer than 2 trillion, and very possibly far beyond. The sober truth is that no one has ever counted them, and no one ever will, because most galaxies are too faint to see, and a great many lie forever past the edge of what we can observe. Tonight we follow that number from a universe once believed to hold only a single galaxy, outward through the hundreds of billions, into the trillions, and at last to the quiet horizon, where all counting runs out. If you find these quiet explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is anything you need to carry. There is nothing here to fear, and nothing you must hold on to. Settle in and let yourself grow still. Let your shoulders soften. Let your breathing slow. Let the day fade gently away. Let's begin. There are questions that seem small until you hold them, and then they open. How many galaxies are there is one of those questions. It can be asked by a child in a single breath, and it can be studied for a lifetime without ever closing. The words are plain, and the answer is anything but. To ask how many galaxies there are is to ask how far the universe reaches, what counts as a galaxy in the first place, and whether a final number is even a thing that can exist. The question is a doorway, and behind it, the room is larger than the house. A galaxy is a great gathering of stars, gas, and dust, bound together by gravity into a single island of light. Around and through it runs a far larger weight of dark matter, unseen but felt, the invisible scaffolding that holds the whole structure in place. The largest galaxies hold many hundreds of billions of stars, turning slowly around a common center across spans of time too long to picture. The smallest hold only a few thousand, a faint scatter of light barely set apart from the dark. Between the grandest spiral and the dimmest smudge lies an enormous range, and somewhere along that range, the very meaning of the word begins to soften. For most of the time that human beings have looked up, the answer to tonight's question was one. The pale band of light arching across a dark sky, the river of faint stars we now call the Milky Way, was understood to be the whole of creation. Everything else was a point of light within it, or a small cloud among its stars. There was no sense of other galaxies, because there was no sense that our own was a galaxy at all. It was simply the sky, and the sky was everything. That single answer held for a very long time, and it was not a foolish one. With the unaided eye, and even with the first modest telescopes, there was no way to know that certain faint smudges among the stars were anything other than nearby clouds of glowing gas. The tools did not yet exist to measure how far away they were, and without distance, there was no way to tell a small near thing from a great far one. The honest count was 1, because 1 was all that could be shown. What makes the story worth telling slowly is that the answer has only ever grown. Each time the instruments improved, the number rose. 1 became many. Many became millions. Millions became hundreds of billions, and hundreds of billions became trillions, and the trillions, as we will see, are almost certainly not the end. There has never once been a revision downward. Every advance in our ability to see has found more galaxies waiting in the dark, and there is no sign that the pattern is finished. It helps, before we begin the climb, to settle 3 quiet uncertainties that shadow every number we will meet tonight. The first is what we choose to count, since the line between a small galaxy and a mere cluster of stars is genuinely blurry. The second is how far out we are willing to look, since we can only ever count the part of the universe whose light has reached us. And the third is when, since looking far across space means looking far back in time, so that any census of galaxies is really a census across the whole history of the cosmos at once. Hold those three uncertainties gently, like three small stones in the hand. They are not problems to be solved, so much as features of the question itself. The number of galaxies depends on where we draw a line, how far we are allowed to see, and which moment in cosmic time we are asking about. Change any one of them, and the answer changes. This is not a failure of astronomy. It is the honest shape of a question that touches the edges of everything. So we will not rush toward a single figure. Instead, we will walk the long road the number has traveled, from a universe of one galaxy to a universe of trillions, and then out past even that to the places no count can follow. Along the way, the sky will keep growing larger and quieter, and the number, rather than landing, will gently lift out of reach. That lifting is not something to resist tonight. It is the whole pleasure of the thing. For now, let the question simply rest, open, and unanswered. How many galaxies are there, really? Let it be the kind of question you do not need to answer in order to enjoy, the way you might watch a slow tide without counting the waves. We have all the time in the world, and the universe is in no hurry to be measured. It is worth being clear, at the outset, about a difference that runs through everything tonight. The difference between the galaxies that exist and the galaxies we can see. These are not the same set, and the gap between them is enormous. We can see galaxies that no longer exist, having merged away long after their light departed. And there exist galaxies we can never see, lying beyond the reach of light in the age of the universe. Any honest count must keep these two ideas apart, because confusing them is the surest way to misunderstand the answer. The dark matter woven through every galaxy is part of why the count matters more than it might seem. A galaxy is not only its visible stars. It is also the great invisible halo of mass that surrounds and pervades it, mass we cannot see but can feel by its gravity. This unseen weight is what lets the smallest, faintest dwarf galaxies count as galaxies at all, and it is part of what separates a true galaxy from a mere huddle of stars. To count galaxies is, in a quiet way, to count these invisible halos as much as the lights inside them. There is also a question of scale that the mind keeps trying to flatten, and it is worth letting it stay large. A single galaxy already contains more stars than a person could name in a lifetime, each star a sun, many of them circled by worlds. And the question tonight is not how many stars, but how many galaxies, how many of these entire star cities there are. We are counting not the windows but the houses, not the trees but the forests. And the number of forests turns out to be one of the largest figures in all of science. None of this needs to be hurried, and none of it needs to be fully grasped to be enjoyed. The pleasure of a question this size is not in pinning it down, but in letting it stretch the mind gently outward, the way a long view from a high place eases the eyes. We will move through it slowly, one idea at a time, with no rush toward a conclusion. The universe has held its galaxies for billions of years without our count, and it will wait patiently while we make our way through the question tonight. Think of the journey ahead as a slow, outward walk, beginning close to home and ending past the edge of sight. We will start in the old universe of one galaxy, watch the count open into many, climb through the hundreds of billions and into the trillions, and finally drift out to the horizons beyond which no counting can follow. At each step, the sky will grow larger and quieter, and the number will grow less certain, not more. That growing uncertainty is not a problem to be fixed. It is the destination itself. And at the center of it all sits the small, ancient pleasure of looking up and wondering. People have stood beneath this same sky for as long as there have been people, and asked, in one form or another, how much is up there? We are the first to be able to answer in the language of trillions, and even our answer dissolves at its edges into the unknown. That is not a defeat. It is the oldest question still being asked, still opening, still larger than every answer we bring to it. To understand how far the count has come, it is worth standing for a while in the old picture, the one in which the Milky Way was everything. It was not a small or mean picture. It was a sky already full of wonder, and the people who held it were not careless. They simply had no way to see past the only galaxy they could find, and so that galaxy became, very reasonably, the universe. The Milky Way reveals itself on a clear night, far from city light, as a soft band of pale brightness, stretching from one horizon to the other. To the unaided eye, it looks like a faint cloud, or a trail of mist laid across the stars. Only through a telescope does the mist resolve into what it truly is, a haze made of countless individual stars, too faint and too crowded to separate without help. That band is the disk of our own galaxy, seen edge on from our place inside it, the combined glow of hundreds of billions of suns. Living inside the galaxy gives us a strange and limited view of it. We cannot step outside and look back at its shape, the way we can photograph a distant spiral. We see it only from within, along the plane of its disk, which is why it appears to us as a band rather than a wheel. Much of what lies across the galaxy is hidden from us behind thick lanes of dust, which dim and redden the light of the stars beyond. For a long time, this inside view made it genuinely difficult to know even the size and shape of our own home, let alone whether anything lay beyond it. Scattered among the familiar stars, early observers also catalogued a number of faint, fuzzy patches that did not sharpen into points, no matter how carefully they were viewed. These soft smudges were given the name nebulae, from an old word for cloud or mist. Some were clearly clouds of gas, lit from within by hot young stars or shed by dying ones. But others had a peculiar character, a faint spiral form, a sense of structure that did not quite fit the idea of a simple cloud. They sat in the catalogues as curiosities, neither fully understood nor easily dismissed. A few bold thinkers looked at those spiral smudges and wondered aloud whether they might be something far grander than clouds. Perhaps, they suggested, each spiral was itself a whole separate system of stars, an island universe, lying at an immense distance, far beyond the edge of the Milky Way. It was a remarkable idea, and an old one, proposed long before there was any means to test it. For generations it remained pure speculation, an elegant possibility with no way to be proved or denied. The trouble, always, was distance. No one could measure how far away the spirals were. This is the center of the old difficulty, and it is worth dwelling on, because distance is the quiet hero of this entire story. A faint smudge in the sky could be a small cloud nearby, or an enormous city of stars unthinkably far away, and from its appearance alone, there is no way to tell the two apart. A candle close at hand and a bonfire far off can cast the same small glow on the eye. Without a reliable way to measure distance, the spirals could not be placed, and if they could not be placed, the size of the universe could not be known. So the question of how many galaxies there were was, for a long age, simply unanswerable, and most astronomers set it gently aside. The reasonable working assumption was that the Milky Way was the whole of things, with the nebulae as features within it. The universe had a size, and that size was the size of our galaxy. Beyond its faint edges, there was assumed to be only darkness, an end to the stars, and nothing more to count. There is something quietly moving in that older universe, and it is worth feeling before we leave it behind. It was a smaller cosmos, but a complete one, a single great wheel of light turning in an unbounded dark, with us somewhere inside it. People lived their whole lives beneath that picture and found it sufficient for wonder. The night sky did not look any less beautiful for being thought smaller. If anything, the sense that this was all there was lent the stars a certain intimacy, as though the whole of creation were gathered into one luminous room. But the spirals would not stay quiet forever. They sat in the catalogues, faint and patient, holding their secret, waiting for a tool sharp enough to read their distance. When that tool finally arrived, the one galaxy would become two, and then the count would never stop climbing again. The wall at the edge of the Milky Way was about to dissolve and reveal itself as the near side of something almost without end. For now, though, let the old sky hold. One galaxy, turning slowly, with everything we knew folded inside it. There is a gentleness in that smaller universe, and no harm in resting there a moment before the walls come down. The stars do not mind being miscounted. They have been patient with us for a very long time. The faint band of the Milky Way has been a presence in human nights for as long as anyone can remember, and the sight of it is worth holding in the mind. Away from the glow of cities, on a clear and moonless night, it arches overhead as a soft river of light, brighter in some stretches, broken by darker lanes in others. Those darker lanes are not gaps in the stars, but clouds of dust, drifting between us and the light beyond, blocking it from view. We are looking through the crowded plane of our own galaxy, and seeing both its light and its shadows. Our position inside the galaxy shapes everything about how we first understood it. Because we sit within the disk, we cannot see our galaxy's spiral shape directly, the way we can photograph a distant one. We see only a band, the disk viewed edge-on, with its far side hidden behind dust and distance. Working out that we live in a great flat spiral, and roughly where within it, took patient effort, piecing together the shape of a structure we can never step outside of to view. We mapped our home from the inside, by inference, the hard way. The faint nebulae that early observers catalogued were a genuine puzzle, and it is worth feeling that puzzle honestly. Some of these soft patches were clearly clouds of gas, glowing within our own galaxy, the nurseries where stars are born, or the shells thrown off by dying ones. But others had a different character, a faint spiral structure, a hint of rotation, a sense of being a system rather than a cloud. They did not behave quite like the gas clouds, and yet there was no way to be sure what they were. They sat in the catalogues as open questions. The idea that some of these spirals might be separate island universes was, for a long time, a beautiful but untestable thought. It had been proposed in various forms by thinkers who reasoned that if the spirals were as large as the Milky Way, but lay at tremendous distances, they would appear exactly as faint and small as they did. But reasoning was not proof. The same faint appearance could equally well belong to a small cloud nearby. Without a measure of distance, the elegant idea could be neither confirmed nor dismissed, and so it waited. This waiting is itself a kind of lesson in how knowledge grows. For generations, the question of whether the universe held one galaxy or many simply could not be answered. Not for lack of thought, but for lack of a tool. The thinking was ready long before the measurement was possible. It is a reminder that some questions are not answered by cleverness alone, but must wait for the means to test them, sometimes for a very long time. The spirals held their secret patiently, until at last a way was found to read their distance. And so the old universe of one galaxy was not a failure of imagination, but a limit of instruments. People had imagined other galaxies. They simply could not prove them. The Milky Way stood as the whole of the cosmos, not because no one dreamed of more, but because no one could yet show it. When the showing finally came, it came not from a grander dream, but from a humble pulsing star, faint inside a distant spiral, whose steady beat would at last let the distance be read and the universe be opened. The wall came down through a particular kind of star, one that keeps a steady and honest rhythm. Certain stars do not shine with a constant light. They brighten and dim, in a slow, regular pulse, swelling and shrinking as their outer layers rise and fall. What makes these pulsing stars precious is a quiet relationship hidden inside their behavior. The slower the pulse, the more light the star truly gives off. The rhythm of the beat reveals the true brightness of the lamp. This relationship is the key that unlocks distance, and the idea behind it is simple enough to hold in the hand. If you know how bright a lamp truly is, and you can see how bright it merely appears, the gap between those two tells you how far away it stands. A streetlight that you know to be powerful, yet which looks faint to your eye, must be far down the road. A pulsing star announces its true brightness through the timing of its beat, and so it becomes a measuring rod, a way to read distance straight off the sky. For nearby pulsing stars within our own galaxy, this method gave distances that fit comfortably inside the Milky Way. The real test came when one of these telltale stars was found inside a faint spiral smudge, one of those long-debated nebulae. Its pulse was timed, and from the pulse its true brightness was known. Set against how faint it actually appeared, the answer was startlingly clear in only one direction. The star was far away, beyond any reasonable measure, far outside the boundaries of the Milky Way by an immense margin. That single faint star settled an argument that had run for generations. The spiral that held it was not a cloud within our galaxy. It was a separate system of stars, an island universe in its own right, lying across a gulf of empty space so wide that the light we saw had been traveling toward us for a very long time. In one measurement, the universe doubled. There were now two galaxies, our own and that distant other. And the second was a great spinning city of stars, not so different from the first. And once there were two, there were many, because the sky was full of these spirals. Every faint pinwheel that had sat in the catalogues as a nebula was at once a candidate galaxy, each one a separate island of hundreds of billions of stars, each one impossibly far away. The Milky Way, which had been the whole universe, shrank in an instant to a single member of an enormous multitude. We were not the cosmos. We were one galaxy among an uncounted crowd, and the crowd reached as far as any telescope could see. It is worth pausing to feel the size of that shift, because it is one of the great, quiet turning points in how we understand our place. In the old picture, the Milky Way was everything, and we sat within the whole. In the new picture, our galaxy became one lit island in an ocean of darkness, scattered with countless others, and our sun became one ordinary star within that one island. The universe did not change. Only our sense of its size did, and it grew, in a single generation, almost beyond recognition. There was no jolt of fear in this discovery, and there need not be one in the telling. The stars were no nearer and no farther than they had always been. What changed was understanding, and understanding, even when it humbles us, has a calm of its own. To learn that home is smaller than you thought, and the world larger, is not a loss. It is a kind of opening, a window thrown wide onto a longer view. The night sky became deeper, and the deepening was a gift. From that moment, the work of astronomy changed. The task was no longer to map the one galaxy and call it the universe, but to count and measure the many, to learn how galaxies are shaped and sorted, how they cluster and drift, and ultimately, how many of them there are. The question we are asking tonight was, in a real sense, born in that instant, when the spirals turned out to be other galaxies, and the counting could finally begin in earnest. The answer would take many lifetimes, and it is still not finished. The distant spiral that broke the wall is still there, of course, the nearest of the great galaxies to our own, a soft smudge that careful eyes can find on a dark autumn night. The light that betrayed its distance is still arriving, still crossing the same wide gulf. Nothing about the galaxy itself was altered by our finally understanding it. It simply turned, as it had always turned, while on a small world, far away, a single faint star within it quietly changed the size of the universe. So the count became many, and the sky filled with islands of light. But many is not a number, and the next task was to ask how many really was. To answer that, astronomers could not visit each galaxy, or even see most of them. They would have to learn to count what they could not fully see, by sampling a small piece of the sky and trusting it to speak for the whole. That is where the hundreds of billions came from, and it is where we turn next. The pulsing stars that broke the wall deserve a closer and slower look, because they are among the most useful objects in all of astronomy. A star of this kind swells and shrinks in a steady cycle, brightening as it expands and dimming as it contracts, keeping a rhythm as regular as a slow heartbeat. The longer the cycle, the more light the star truly pours out. This link between the rhythm and the true brightness is the gift, because rhythm is something we can measure from any distance, simply by watching and timing the beat. From that rhythm, distance follows by a clean chain of reasoning. Watch the star, time its cycle, and you know how bright it truly is. Then measure how bright it merely appears in your telescope, and the difference between true and apparent brightness gives the distance, since light fades in a known way as it spreads across space. A bright lamp that looks faint must be far. A pulsing star announces its true wattage through its beat, and so becomes a measuring rod that can be laid across the gulfs between the galaxies. When such a star was found inside one of the disputed spirals, the measurement was decisive in a way that admitted no argument. Its rhythm gave its true brightness. Its faint appearance, set against that true brightness, placed it at a distance far beyond any possible edge of the Milky Way. The spiral that held it could not be a nearby cloud. It had to be a separate system of stars, enormous and remote, an island universe in the full sense that had only been guessed at before. The guess became a measurement, and the measurement settled everything. What followed was not a single new galaxy, but a flood of them. Every spiral smudge in the catalogues, once it could be understood as a distant galaxy, became one. The sky was full of spirals, and so the sky was full of galaxies, each a city of hundreds of billions of stars, each impossibly far away. In the space of a generation, the universe went from holding one galaxy to holding more than anyone could easily count, and the work of astronomy shifted from mapping our galaxy to surveying a cosmos of them. With the many galaxies came variety, and the variety was its own quiet revelation. The galaxies were not all alike. Some were grand spirals with sweeping arms, like our own. Others were smooth ellipticals, featureless golden ovals of old stars. Others still were irregular, ragged with star formation, or small and faint and hard to classify. The universe was not just full of galaxies, but full of kinds of galaxies, a whole natural history of star cities waiting to be sorted and understood, each kind with its own story of formation and change. It is worth sitting for a moment with how recent all of this is in the long view. For nearly all of human history, the count was one. The opening of that one into many is a young piece of knowledge, younger than many of the buildings people live in. We are among the first generations to know that we live in a galaxy among countless others, rather than in the single galaxy that is all there is. That knowledge is still fresh, still settling into us, and there is a quiet privilege in holding it. Once it was clear that galaxies were many, the obvious question was how many, and the obvious approach was to count them. But the obvious approach fails almost at once, because there are far too many galaxies to count one by one, and the great majority are far too faint to see at all without enormous effort. So astronomers turn to a method that does not require seeing everything. They would count a small, carefully chosen piece of the sky with great care, and then reason outward from that piece to the whole. The method begins with a choice that sounds almost perverse. Rather than pointing a great telescope at something bright and famous, astronomers chose a small patch of sky that looked as empty and ordinary as possible, a dark window with no bright nearby stars and nothing remarkable in it. The point was to find a piece of sky that was typical, unblessed by any special object, so that whatever it contained could stand in fairly for the rest. They aimed at the nearest thing the sky offers to nothing at all. Then they held the gaze. A single short look gathers only the brightest light, but a long exposure, held steady for many hours and even days, lets the faintest light slowly accumulate, photon by patient photon, until things appear that no brief look could reveal. As the exposure lengthened, the empty window stopped being empty. Out of the dark came galaxies, faint and small at first, then more and more of them, until the supposedly blank patch was crowded with them, layered front to back across unthinkable distances. The result was humbling in the gentlest way. A piece of sky so small that it could be covered by a grain of sand, held at arm's length, a window onto what had looked like pure darkness, turned out to contain several thousand galaxies. Not stars, galaxies, each one a city of hundreds of billions of suns, packed into a scrap of sky most people would have sworn held nothing at all. The darkness between the stars was not empty. It was full, and full of the same kind of grandeur as our own galaxy, simply too far away to see without patience. From a single sampled window, the count of the whole sky follows by a simple and powerful kind of reasoning. The little window covers a known and tiny fraction of the entire sphere of the sky. If that window holds several thousand galaxies, and you know how many such windows it would take to tile the whole sky from horizon to horizon and all the way around, then multiplying gives an estimate for the entire observable universe. You count the leaves on one measured branch, and you reason out the forest. When that multiplication was carried out, it gave a number that became one of the famous facts of astronomy. The observable universe appeared to hold somewhere between 1 and 200 billion galaxies. That figure settled into textbooks and lectures and quiet moments of wonder for a long span of time. 200 billion galaxies, each with its own hundreds of billions of stars, was already a number past any real grasp, and for a long while, it stood as the answer to tonight's question. The reasoning behind it rests on an assumption worth saying plainly, because it is both reasonable and necessary. The method assumes that our chosen window is typical, that the universe looks broadly the same in every direction and in every random patch, with no special crowding or emptiness where we happen to look. This idea, that the cosmos is much the same everywhere on the largest scales is one of the quiet foundations of modern astronomy, and it has held up well. The universe does appear, when viewed broadly enough, to be remarkably even-handed about where it puts its galaxies. There is a real beauty in this way of knowing, and it rewards a slow look. We cannot count the galaxies, and we never will, and yet by counting a single grain's worth of sky we can responsibly estimate the whole. It is the same trick by which one might estimate the sand on a shoreline without lifting each grain, or the leaves on a summer tree without touching each leaf. You measure carefully what you can reach. You learn the rule by which the small relates to the large, and you trust the rule to carry you the rest of the way. And yet 200 billion, for all its grandeur, carried a quiet flaw inside it, one that would eventually lift the number tenfold. The long-exposure images counted the galaxies bright enough and large enough to be seen directly in the picture. But brightness is not the same as existence. For every galaxy luminous enough to register, there might be many more too faint to leave any mark at all, hidden below the threshold of even the longest exposure. The count was a count of what could be seen, and what could be seen was only ever part of the story. So the hundreds of billions, though they stood for a long time, were a floor and not a ceiling. They were the galaxies the light could show us, the bright tip of something larger and dimmer. To find the rest, astronomers would have to reckon with the galaxies they could not see directly at all, the faint multitude waiting beneath the surface of every image. When they did, the number would not merely grow, it would leap. The deliberate choice to point a great telescope at apparent nothingness is one of the quietly bold acts in the history of looking. The instinct is always to aim at something, a bright star, a known galaxy, a famous object. To aim instead at a small dark patch chosen precisely because it seemed empty was a kind of faith, a wager that the darkness was not truly empty, but only faint. The wager paid off beyond expectation. The chosen emptiness turned out to be crowded, and the crowd was made of galaxies. The image that emerged from that long stare rewards slow description. Across a tiny scrap of sky appeared galaxies of every kind and distance, layered in depth. Near, bright spirals shared the frame with faint, far smudges, so distant their light had traveled most of the age of the universe. Some were caught mid-collision, drawn into long, bright tails by each other's gravity. Others sat alone, small and red and ancient. A single small window held a cross-section of the entire history of galaxies, near and far, young and old, all at once. Counting that window and scaling to the whole sky gave the famous figure, but the reasoning deserves to be felt rather than just stated. The window covered a known and tiny fraction of the sky. Multiply the galaxies in it by the number of such windows needed to tile the entire celestial sphere, and the count of the whole observable universe follows. From a grain of sky, the forest. It is the same logic by which a careful sample can stand for a whole, trusted because the universe appears much the same wherever we point. That trust, the assumption that our patch of sky is typical, is worth examining gently because the whole method rests on it. If we had happened to look at an unusually crowded or unusually empty region, our scaled-up count would be wrong. But the universe, viewed on large enough scales, does appear remarkably even, with galaxies spread through it in much the same density everywhere we look. This evenness is one of the quiet foundations of cosmology, and it is what lets a single sampled window speak honestly for the whole wide sky. The figure that resulted, 1 to 200 billion galaxies, settled into the common understanding for a long time, and it is worth pausing to honor it. It was a careful number, honestly arrived at, and it was already past comprehension. 200 billion galaxies, each with its own hundreds of billions of stars, was a universe of staggering richness. For a long span, it stood as the answer, taught and repeated and wondered at, a number that seemed as large as any number could reasonably need to be. And yet, even as it was taught, the figure carried the seed of its own revision. It counted only the galaxies bright enough to be seen, and brightness is not the same as being. Below the floor of even the longest exposure lay an unknown multitude of fainter galaxies, real but undetected, waiting beneath the threshold of every image. The hundreds of billions were the galaxies the light could show. The rest had to be reasoned out, and when they were, the number would climb past anything the famous figure had suggested. It is worth remembering, too, that the long exposure does not only reveal galaxies, but sorts them by distance, through their faintness and their color, so that a single image becomes a kind of timeline. The nearer galaxies, larger and brighter, sit in the foreground. Behind them lie smaller, redder, more distant ones, their light older, their form younger. To count such an image is to count across the whole reach of cosmic history in one frame, which is part of why the method is so powerful and so humbling at once. And there is a quiet discipline in choosing where to look that is easy to overlook. The patch of sky must be ordinary, free of bright nearby stars whose glare would drown the faint distant light, and clear of thick dust that would block the view outward. Astronomers seek out the emptiest, most unremarkable windows precisely so that what they find can stand fairly for the whole. The famous counts come not from the grandest corners of the sky, but from its plainest, chosen for being typical rather than spectacular. The number jumped, and it is important to understand that the universe did not. 200 billion did not become 2 trillion because new galaxies were born, or because the cosmos abruptly grew. It happened because the counting grew more honest. The earlier figure had quietly left out the galaxies too faint to be seen, and when astronomers found a way to account for those missing multitudes, the total rose by more than tenfold in a single careful reckoning. The key lies in how galaxies are distributed by size and brightness, a pattern that turns out to be wonderfully regular. There are not equal numbers of large and small galaxies. Instead, for every great luminous galaxy, there are many modest ones, and for every modest one, there are many more that are smaller and fainter still. The number rises steadily as the galaxies grow dimmer, following a smooth and predictable relationship. The universe is built far more of small, faint galaxies than of grand, bright ones, in much the way a forest holds far more saplings and seedlings than ancient towering trees. This pattern is the bridge across the gap between what we see and what is there. An image, however long the exposure, has a flaw, a level of faintness below which galaxies simply do not register. Everything dimmer than that flaw is real but invisible to that picture. But if we know the rule by which faint galaxies outnumber bright ones, we can follow that rule downward, past the floor of the image, and estimate how many galaxies must be hiding in the dark below the threshold. We cannot see them one by one, but we can count them as a crowd. When that reckoning was done, extending the count down into the realm of galaxies too faint to detect individually, the total climbed to roughly 2 trillion within the observable universe. 2 trillion galaxies, where for so long the answer had been 200 billion. The leap did not come from a bigger telescope finding new objects, so much as from a more honest accounting of the faint ones that had been there all along, beneath the reach of every earlier image. It is worth feeling the size of that correction, slowly, because it changes the texture of the whole night sky. If the count is 2 trillion, and only a couple of 100 billion were ever bright enough to be seen and tallied directly, then roughly 19 out of every 20 galaxies in the estimate are too faint to have ever been photographed as individual things. The grand spirals and ellipticals we admire in pictures are the bright, rare exceptions. The true population of the universe is overwhelmingly made of small, dim galaxies fading down into invisibility. Much of that faint multitude lived long ago in the young universe, and this is part of why the long-exposure images find so many of them. When we look far across space, we look far back in time, and the early cosmos was crowded with small galaxies that had not yet grown or merged. Many of those early small galaxies have since fallen together into the larger galaxies we see nearby. The 2 trillion count includes a great host of galaxies from the universe's youth, some of which no longer exist as separate things, having long since merged away. So the number 2 trillion carries a subtlety folded inside it, one worth holding gently. It is not a snapshot of how many galaxies exist at this single moment. It is a count spread across the whole history we can see, mixing the crowded small galaxies of the early universe with the fewer, larger galaxies of the present. The figure is honest, but it is a figure about everything we can observe across all of cosmic time, not a tidy inventory of the here and now. Even so, 2 trillion is the number most often given today when someone asks how many galaxies there are. It is a careful, considered estimate, built not only from what the longest exposures reveal, but from a principled reckoning of all the faint galaxies that must lie below them. It represents our best honest accounting of the galaxies within reach of our sight. And it is, almost certainly, still not the whole story, because the newest instruments have begun to complicate it once again. There is a quiet lesson in this leap that is worth carrying through the rest of the night. Every time we have looked harder, the universe has turned out to hold more than we thought, not less. The count has climbed from 1 to many, from many to hundreds of billions, from hundreds of billions to trillions, and at no step has it ever reversed. Each improvement in our seeing has revealed a fuller, more crowded cosmos than the one we had imagined the moment before. And so the faint galaxies, which once went uncounted, turn out to be the true majority. The bright ones we can see are the small, visible portion of a far larger whole, the few lit windows of an enormous, darkened house. To ask how many galaxies there are is, in the end, mostly to ask how many faint ones lie just beyond the reach of our best images, fading down and down toward a floor we have not yet found. That is a question we answer not by seeing, but by reasoning, and the answer keeps growing. To feel why the count leaped, it helps to picture the population of galaxies sorted by brightness, like a crowd sorted by height. There are a few towering giants, more of middling size, and then a great and growing throng of the small and faint, more numerous at every step down the scale. This is not a vague impression, but a measured and regular pattern. The fainter the galaxies, the more of them there are, rising smoothly without any sign of stopping, down past the limit of what any image can show. This regular pattern is exactly what lets the unseen be counted. Because the relationship between brightness and number is smooth and predictable, astronomers can follow it downward, below the floor of the image, and estimate how many galaxies must lie hidden in the faint dark beneath the threshold. They cannot see those galaxies one by one, but they can count them as a population, the way one might estimate the unseen roots of a forest from the visible pattern of its trees. The faint majority is counted not by sight, but by the rule. When that reasoning was carried through, the figure rose to roughly 2 trillion galaxies within the observable universe, and the size of that jump rewards a slow appreciation. From 200 billion to 2 trillion is a 10-fold climb, which means that for every galaxy bright enough to have been counted directly, there are roughly 9 more too faint to have ever been seen as individual things. The universe we can photograph is the bright tip. The far larger part is dim, and was there all along, waiting beneath the reach of our images. Much of that faint multitude belongs to the early universe, and this deepens the meaning of the count. When we look far across space, we look far back in time, and the young cosmos was crowded with small galaxies that had not yet grown or merged. Many of those early small galaxies have since fallen together into the larger ones we see nearby. So the 2 trillion includes a great host of galaxies from the universe's youth, counted as they were long ago, some of which no longer exist as separate things at all. This is why the figure 2 trillion must be held with a particular care. It is not a count of how many galaxies exist at this present instant. It is a count spread across all the time we can see, blending the crowded small galaxies of the distant past with the fewer larger galaxies of the recent universe. The number is honest, but it answers a subtle question. How many galaxies appear across the whole visible sweep of cosmic history, rather than the simpler sounding but harder question of how many exist right now? Even with all these subtleties, 2 trillion stands as the working answer of our time, and it carries the night's quietest lesson within it. Every time we have learned to see more faintly, the universe has turned out to hold more galaxies than we thought. The count has climbed at every step and reversed at none. The faint galaxies, once invisible and uncounted, are the true majority, and the bright ones we admire are the rare exceptions. The real universe is dimmer, fuller, and far more crowded than the one our images first revealed. It is one thing to say that a long exposure of an empty patch of sky reveals thousands of galaxies. It is another to understand how astronomers turn that image into a number and into a map. The counting rests on a small set of patient techniques, each one a quiet marvel, and it is worth walking through them slowly, because they are how we know almost everything we know about the reach of the universe. The first technique is the long exposure itself, which acts like a core sample drilled straight through the sky. A short look gathers only the brightest, nearest light. But light is patient, and a detector held steady for hours and days keeps collecting it, grain by grain, until the faintest and most distant galaxies slowly rise out of the dark. Because farther galaxies are also older, a single long exposure captures galaxies from many different eras at once, layered front to back, the near and recent in front, the far and ancient behind. One image becomes a slice through both space and time. The second technique is the leap from a small window to the whole sky. The sampled patch covers a known and minuscule fraction of the celestial sphere. By counting the galaxies in that patch and multiplying by the number of such patches it would take to cover the entire sky, astronomers arrive at an estimate for the whole observable universe. The reasoning leans on the gentle assumption that our patch is ordinary, that the universe is much the same in every direction, an assumption that has held up well under every test. The third technique corrects for what the image cannot show. Every picture has a floor of faintness beneath which galaxies vanish, so the raw count always undercounts. To fix this, astronomers study the smooth relationship by which faint galaxies outnumber bright ones, and they extend that relationship downward, past the floor of the image, estimating how many galaxies must be hiding below the threshold. This single correction is what carried the count from hundreds of billions up into the trillions. It counts the unseen by trusting the pattern of the seen. The fourth technique reads distance from color, and it depends on the expansion of space itself. As the universe expands, it stretches the light traveling across it, shifting that light toward the red end of the spectrum. The farther away a galaxy lies, the longer its light has traveled and the more it has been stretched. By measuring how far a galaxy's light has shifted toward red, astronomers can read its distance, and therefore its age, since farther always means longer ago. The flat image becomes a three-dimensional map sorted by depth in time. This color reading matters enormously for the count, because it tells a faint galaxy's true nature. A small, dim smudge could be a modest galaxy, lying fairly close, or a genuinely enormous one at a tremendous distance, and from brightness alone, the two cannot be told apart. The stretch of its light resolves the ambiguity, placing each galaxy at its proper distance and era. Without it, the layered image would be a flat confusion. With it, the universe sorts itself into a clear sequence, near to far, recent to ancient. There is a fifth technique, quieter than the others, that serves as a check on the whole enterprise. Astronomers can measure the total faint glow of the sky once every known star and galaxy has been carefully subtracted away. Whatever soft background remains is, in part, the summed light of all the galaxies too faint to be picked out one by one. Comparing that leftover glow to the light of the galaxies actually counted gives an independent sense of how much is being missed below the threshold of every image. That cross-check holds a small and gentle puzzle inside it. When the leftover background light is measured carefully, it sometimes appears slightly brighter than the counted galaxies can fully explain. The glow is a touch greater than expected, as though there were a little more faint light out there than the census accounts for. No one is alarmed by this. It is the kind of soft, unresolved question that astronomy is full of, a hint that the faint population may run even fuller and dimmer than our best estimates suggest. Taken together, these techniques are how the impossible becomes merely difficult. We cannot count 2 trillion galaxies, and we never will, but by sampling a grain of sky, learning the rule by which faint follows bright, reading distance from the stretch of light, and checking the total against the background glow, we can responsibly estimate the whole. It is a structure of careful reasoning built on a few patient measurements, and it lets us speak honestly about numbers no one could ever tally by hand. There is a calm beauty in knowing this way, and it rewards a slow appreciation. The count of the galaxies is not a guess and not a fancy. It is a considered estimate, drawn from real light gathered over real hours, extended by a rule we have tested and cross-checked against the faint glow of everything at once. We arrive at trillions, not by seeing them, but by understanding the sky well enough to know what must be hidden in it. And even then, the number is only the part we are allowed to reach. The expansion of space that stretches light toward red is worth dwelling on, because it is the engine behind one of our most powerful tools. As the universe grows, the space through which light travels grows with it, and a wave of light is stretched along with that space, its color shifted toward the red end of the spectrum. The farther the light has traveled, the more space has grown beneath it, and the more its color has shifted. The redness of a galaxy's light becomes a direct reading of how far and how long ago it set out. This color reading is what turns that image into a map with depth, and the depth is also depth in time. A single picture of the sky holds galaxies at every distance, layered front to back, but the picture alone cannot say which faint smudge is near and which is far. The stretch of each galaxy's light resolves it, placing every galaxy at its true distance and era. The image sorts itself into a sequence, near and recent in front, far and ancient behind, a cross-section through the history of the universe. Without this sorting, the count would be a confusion, and it is worth seeing why. A small, faint smudge could be a modest galaxy lying fairly close, or an immense one at a tremendous distance, and from brightness alone the two are indistinguishable. Reading the stretch of its light tells them apart, and so lets each galaxy be placed and counted properly. The technique is not a luxury. It is what makes a responsible census possible at all, turning a flat scatter of smudges into an ordered map of real galaxies at real distances. The cross-check from the total background glow deserves its own slow look because it is a beautiful piece of reasoning. Subtract every known star and galaxy from the light of the sky, and a faint background remains. Part of that leftover glow is the summed light of all the galaxies too faint to be picked out one by one. By comparing this total glow to the light of the galaxies actually counted, astronomers gain an independent check on how much is being missed, a second path to the same answer that does not depend on counting individual galaxies at all. And that cross-check holds a small, gentle puzzle, the kind astronomy is quietly full of. When the background glow is measured carefully, it sometimes seems a little brighter than the counted galaxies can fully account for, as though there was slightly more faint light out there than the census explains. No one is troubled by this. It is a soft, open question, a hint that the faint population may run even fuller and dimmer than our best estimates suggest. The universe, looked at closely, almost always has a little more in it than we have managed to count. Taken together, these methods are how we speak honestly about numbers no one could ever tally by hand. We sample a grain of sky, learn the rule by which faint follows bright, read distance from the stretch of light, and check the total against the faint glow of everything at once. From these patient measurements comes a considered estimate of trillions, arrived at not by seeing every galaxy, but by understanding the sky well enough to know what must be hidden in it. The count is reasoned as much as seen, and it is the better for it. It is worth adding that none of these methods stands alone, and their real strength is in agreement. The count from sampling the sky, the rule by which faint galaxies outnumber bright, the distances read from stretched light, and the check from the total background glow are independent paths, and they point toward the same enormous answer. When several different ways of reasoning, leaning on different measurements, arrive together at trillions, the figure earns a confidence that no single method could give it. The number is not one estimate, but a convergence. The grand galaxies are the ones we picture when we hear the word. Great spirals with sweeping arms, smooth golden ellipticals, great wheels of light turning in the dark. These are the galaxies that fill the famous images, and they are genuinely magnificent. But they are also, in the great accounting of the universe, the rare exceptions. The true population of galaxies is something humbler and far more numerous, and to understand the count, we have to look not at the giants, but at the small. For every great galaxy like our own, there are many small ones, modest clouds of stars, called dwarf galaxies. A dwarf galaxy might hold a few 100 million stars, or a few million, or in the smallest cases, only a few thousand. It is a galaxy nonetheless, a system bound together by its own gravity and its own halo of dark matter, separate from its neighbors. Dwarfs are dim, often little more than a faint haze, and they are easy to overlook. But they are, by an enormous margin, the most common kind of galaxy in the universe. This changes the whole texture of the count. When we say 2 trillion galaxies, we are not picturing 2 trillion grand spirals. The overwhelming majority of that number is dwarfs, small and faint and unassuming. The bright galaxies are a thin scattering of exceptions, riding atop a great sea of modest ones. A census of galaxies is, almost entirely, a census of dwarfs, and the giants are a rounding detail by comparison, the rare tall trees in a forest made mostly of underbrush. Many dwarf galaxies live in the company of larger ones, orbiting a great galaxy as satellites the way moons orbit a planet. Our own galaxy is attended by a retinue of such dwarf companions, some bright enough to have been known since antiquity as soft patches in southern skies, others so faint they escaped all notice until careful modern surveys. A great galaxy is rarely alone. It is usually the center of a small household of dwarfs, drawn in by its gravity, slowly orbiting, sometimes slowly being consumed. The smallest dwarfs blur the very idea of a galaxy, and this is where the count grows genuinely uncertain. A dwarf with only a few thousand stars is barely more than a loose gathering of light, and it can be hard to say, with confidence, whether it is a true galaxy or merely a cluster of stars that happens to drift together. The difference matters for the count, because if the faintest dwarfs are counted as galaxies, the universe holds far more of them than of anything bright. The number depends on where, exactly, we decide a smudge stops being a galaxy. What tends to mark a dwarf as a true galaxy rather than a mere cluster is the unseen weight around it. Galaxies appear to sit inside their own halos of dark matter, the invisible mass that helped them form and that holds them together. Even the faintest dwarf galaxies seem to carry far more of this dark weight than their few visible stars could account for, and this is part of why astronomers still count them as galaxies in their own right. A star cluster, by contrast, is just stars, formed together in a single batch, with no great halo of its own. The faintest dwarfs are also some of the oldest and quietest objects in the universe, and there is a particular gentleness in them. They formed early, made their modest handful of stars, and then largely went still, their star making long finished. They drift now as faint relics of the young cosmos, holding stars older than almost anything else, turning quietly at the edges of larger galaxies, or alone in the dark. They are easy to miss and easy to underestimate, and yet they are the true majority of the inhabited universe. Every survey that looks harder finds more of them, and there is no sign the supply is running out. New faint dwarfs keep turning up even close to home, orbiting our own galaxy, hidden until a patient search teased them out of the background of brighter stars. If they are this easy to overlook nearby, then the universe must be salted with countless faint dwarfs we have not yet found, near and far alike. Each one is a galaxy, and each one belongs in the count, and most of them remain entirely unknown to us. So the honest picture of the galactic population is upside down from the famous one. The grand spirals and ellipticals that fill our imaginations are the rare bright minority. The real universe is mostly small, mostly faint, mostly dwarfs, fading down through ever dimmer and ever more numerous forms, until they blur into the dark and into the very definition of what a galaxy is. The count is dominated not by the magnificent, but by the modest, and the modest are almost beyond number. This is why the question of how many galaxies there are can never be cleanly answered, even setting aside the limits of our sight. The answer depends on how faint a thing we are willing to call a galaxy, and the fainter we are willing to go, the more there are, with no obvious place to stop. The count does not end at a clear boundary. It trails off downward into smaller and dimmer objects, into a continuum where galaxy slowly becomes cluster, becomes a mere wisp of stars, and our counting must simply choose where to lay down its pen. The dominance of dwarf galaxies in the count is worth letting reshape the mental picture entirely. When we say 2 trillion galaxies, the image that comes to mind is 2 trillion grand spirals, sweeping and luminous. But that picture is upside down. The great majority of those galaxies are small, faint dwarfs, modest clouds of stars far dimmer and far more numerous than the giants. The spirals and ellipticals that fill the famous images are the rare bright exceptions, riding atop a great and quiet sea of the small. These dwarf galaxies come in a range of their own, from the relatively substantial down to the almost unimaginably faint. Some hold a few 100 million stars and make a soft, visible glow. Others hold only a few million or a few 100,000, fading toward the threshold of detection. And at the very bottom are the ultra-faint dwarfs, holding perhaps only a few thousand stars, so dim that even close to home they escaped all notice until patient searches teased them from the background. Each is a galaxy, and each belongs in the count. The unseen weight around these dwarfs is what marks them as true galaxies, and it is a quietly profound point. Even the faintest dwarf galaxies, with only a handful of stars, appear to carry far more mass than those stars can account for, held within a great halo of dark matter many times heavier than everything that shines. This invisible weight is part of what separates a dwarf galaxy from a mere star cluster. A galaxy sits within its own halo of dark matter. A cluster is just stars, with no great unseen mass of its own. Many dwarfs live as companions to larger galaxies, and this gives the universe a kind of household structure worth picturing. A great galaxy is rarely alone. It is usually attended by a retinue of smaller dwarf galaxies, orbiting it the way moons orbit a planet, drawn in by its gravity. Our own galaxy carries such a household, some companions bright enough to have been known since ancient times as soft patches in southern skies, others so faint they were found only by careful modern searching. The giants are centers of small families of the dim. The faintest dwarfs are also among the oldest and quietest things in the universe, and there is a tenderness in them worth feeling. They formed early, made their modest handful of stars, and then largely went still, their star making long finished. They drift now as faint relics of the young cosmos, holding stars older than almost anything else, turning slowly at the edges of larger galaxies, or alone in the dark. Easy to miss and easy to underestimate, they are nonetheless the true and numerous majority of the inhabited universe. And every search that looks harder finds more of them, with no sign the supply is exhausted. New faint dwarfs keep appearing even close to home, orbiting our own galaxy, hidden until a patient survey drew them out of the crowd of brighter stars. If they are this easy to overlook nearby, the universe must be salted with countless faint dwarfs we have not yet found, near and far alike. Each is a galaxy that belongs in the count, and most of them remain entirely unknown to us, waiting in the dim for a sharper look. The hardest part of counting galaxies is not reaching the faint ones or the far ones. It is deciding what a galaxy is at the blurry bottom of the scale, where the smallest galaxies and the largest star clusters come to resemble one another so closely that even careful astronomers disagree. This is not a failure of measurement. It is a genuine fuzziness in nature, a place where one kind of thing shades smoothly into another, with no sharp line between. Picture the range of objects that hold stars together. At one end are the great galaxies, unmistakable. At the other are small star clusters, tight balls of stars that everyone agrees are merely parts of a galaxy, not galaxies themselves. But in the middle lies a crowded and ambiguous territory, where small faint galaxies and large dense clusters overlap. An object there might hold a few thousand stars in a modest glow, and from its appearance alone, there may be no clear way to say which category it belongs to. The working distinction rests mainly on two quiet questions. The first is whether the object sits inside its own halo of dark matter, the invisible mass that marks a true galaxy. The second is how the object formed, whether it came together as its own independent system or whether it was born as a single batch of stars within a larger galaxy. A galaxy has its own dark halo and its own origin story. A cluster is just stars, formed together, embedded in a galaxy that is not them. But measuring these things at the faint edge is difficult, and the answers are not always clear. Some objects sit so precisely on the line that they have been argued over at length, classified one way and then the other as new measurements come in. An unusually large, bright cluster might be the stripped remnant core of a small galaxy that was torn apart, in which case it was once a galaxy, and arguably still is. A faint, diffuse galaxy might be so thin and starved that it barely qualifies, drifting near the threshold of the very definition. These ambiguous cases are not rare oddities. They are the natural population of the boundary zone. This matters for the count in a way that is easy to underestimate. Because faint small objects so greatly outnumber bright large ones, the total number of galaxies is far more sensitive to where we draw the lower boundary than to anything about the giants. Shift the line slightly so that a class of borderline objects counts as galaxies, and the total leaps. Shift it the other way, and the total falls. The grand galaxies barely move the number. The argument at the faint edge moves it enormously. So the boundary between galaxy and cluster is not only a question of definition, it is one of the largest sources of uncertainty in the entire count. The difference between a universe of 1 trillion galaxies and one of several trillion may rest less on what we can see and more on where we choose to set the threshold of the word. The number is, in part, a decision rather than a discovery, a line drawn by us across a continuum that nature left smooth. There is something quietly fitting in this, and it rewards a slow and easy acceptance. The universe did not build its galaxies to match our categories. It made a smooth range of objects, from the grandest spirals down to the faintest wisps, with no clean breaks anywhere along the way. The boundaries are ours, laid down for convenience, useful but not fundamental. When we ask how many galaxies there are, we are partly asking how we have chosen to carve up a reality that does not come pre-divided. This does not make the count meaningless, only honest about its own nature. We can still say, with real confidence, that there are at least 2 trillion galaxies within reach of our sight by any reasonable definition. What we cannot do is name a single, exact, and final number, because the faint edge has no sharp bottom and the definition has no perfect line. The count is real, and it is also, at its lower border, a little bit a matter of where we choose to stand. It helps to hold this lightly, the way one holds any boundary that turns out to be softer than it looked. The line between dusk and night, between a hill and a mountain, between a pond and a lake, is always a little arbitrary, drawn by us across a smooth change. The line between a small galaxy and a large cluster is the same kind of line. The objects are perfectly real. It is only the fence we run between them that is a human invention, and the count inherits the softness of that fence. So, even before we reach the true limits of our sight, the number of galaxies refuses to settle into a single clean figure. It floats within a range, set partly by what we can detect and partly by how we have chosen to define the smallest members. And this is only the uncertainty within the part of the universe we can see. The deeper limit, the one that places a real and permanent ceiling on any count, is not about definition at all. It is about the edge of the observable universe, and to that edge we now turn. The territory where small galaxies and large clusters overlap is worth exploring slowly, because it is where the count grows genuinely soft. Imagine the full range of objects that hold stars together, laid out from the grandest galaxy to the smallest tight cluster. At the top, the giants are unmistakable galaxies. At the bottom, the small clusters are unmistakably mere parts of a galaxy. But in the middle lies a crowded, ambiguous zone where small, faint galaxies and large, dense clusters come to look so alike that even careful astronomers cannot always tell them apart. The two questions that sort this middle zone are quiet ones, but they carry the whole weight of the distinction. The first is whether the object sits within its own halo of dark matter, the invisible mass that marks a true galaxy. The second is how the object formed, whether it came together as its own independent system or was born as a single batch of stars inside a larger galaxy. A galaxy has its own dark halo and its own origin. A cluster is just stars formed together, embedded in a galaxy that is not them. But these things are hard to measure at the faint edge. Some objects sit so squarely on the line that they have been classified one way and then the other as new measurements arrived. An unusually large, bright cluster might turn out to be the stripped remnant core of a small galaxy that was torn apart by a larger one, in which case it was a galaxy once and arguably still is. A faint, diffuse galaxy, thin and starved and barely held together, might sit so near the threshold of the definition that its status is genuinely unclear. These are not rare oddities but the natural inhabitants of the boundary. Why this matters so much for the count comes back to the lopsided population. Because faint small objects so greatly outnumber bright large ones, the total number of galaxies is far more sensitive to where we set the lower boundary than to anything about the giants. Shift the line slightly so that a whole class of borderline objects counts as galaxies and the total leaps. Shift it the other way, and the total falls. The magnificent galaxies barely move the number. The quiet argument at the faint edge moves it enormously. There is a gentle philosophical truth in all of this, and it is worth receiving without strain. The universe did not build its galaxies to match our categories. It made a smooth range of objects, from the grandest spirals down to the faintest wisps, with no clean breaks anywhere. The boundaries are ours, drawn for convenience, useful but not fundamental. When we ask how many galaxies there are, we are partly asking how we have chosen to divide a reality that nature left undivided, smooth and continuous from top to bottom. This softness at the lower edge does not make the count meaningless, only honest about itself. We can still say with real confidence that there are at least 2 trillion galaxies within reach of our sight, by any reasonable definition. What we cannot do is name one exact and final figure, because the faint edge has no sharp bottom, and the word galaxy has no perfect lower boundary. The count is real and useful, and it is also, at its faint border, partly a matter of where we have chosen to stand and lay down our line. Every number we have reached tonight, the hundreds of billions, the 2 trillion, the uncertain range beyond, shares a hidden boundary. They are all counts within the observable universe, the part of the cosmos whose light has had time to reach us. Beyond that boundary lie almost certainly more galaxies, perhaps far more, but we cannot count them because we cannot see them, and we cannot see them because their light has not yet arrived. The edge of our counting is not the edge of the universe. It is the edge of what time has allowed us to observe. The observable universe has an edge for a reason that is gentle once it is understood. Light travels quickly, but not instantly, and the universe has existed for only a finite span. In all the time since the beginning, light from the most distant regions has been traveling toward us. But there are regions so far away that their light has not yet had time to complete the journey. We see only as far as light has been able to reach in the age of the cosmos. Past that, the universe surely continues, but it is, for now, simply out of view. This means the edge of the observable universe is not a wall in space, but a horizon in time. It is a boundary much like the horizon at sea, which is not an edge of the ocean but only the limit of how far you can see from where you stand. Move, and the horizon moves with you. The universe does not end where our sight ends. There is simply more of it than light has had time to show us, and the boundary marks the reach of light, not the reach of being. Because looking far means looking back. The most distant galaxies we can see are seen as they were in the universe's youth. Their light has been traveling for almost the entire age of the cosmos, and it shows them not as they are now, but as they were long ago, young and forming, near the beginning of things. We never see distant galaxies in their present state. We see only their ancient light, a portrait of a past that finished unfolding before that light ever reached us. And here the count grows subtle in a way worth holding slowly. Many of the faint, distant galaxies we count in the early universe have, in the long ages since their light departed, merged together into larger galaxies. The galaxy we are counting may no longer exist as a separate thing. Its light still arrives, carrying the image of something that has since become part of something else. So the observable count includes galaxies that are, in the present, already gone, folded into others. Their separate existence ended long before we ever saw them. This is why the number of galaxies that exist right now is smaller than the number we can see. The count we make across the observable universe mixes the crowded small galaxies of the early cosmos, many since merged away, with the fewer larger galaxies of the present. To see is to look into the past, and the past was more crowded with small galaxies than the present is. The 2 trillion is a count across all of visible time, not a snapshot of the single present moment, which holds fewer separate galaxies than the long view suggests. There is no way around this limit, and it is not a flaw to be fixed. It is woven into the nature of light and time. We are beings who see by light that takes time to travel, living in a universe of finite age, and so we are permanently fixed at the center of a sphere of sight whose edge is set by how far light has come. Everything beyond that sphere is real and forever uncounted, not because we lack the instruments, but because the light has not arrived, and in many cases, never will. So when we give a number for the galaxies, even our best and largest number, we should hear the quiet words hidden inside it. 2 trillion galaxies that we can see. The phrase that we can see is not a small qualification. It is the whole boundary of the count. The real universe extends past our sphere of sight in every direction, holding who knows how many more galaxies in regions whose light will reach us late or never. Our count is a count of the lit room. The house is larger, and most of it is dark to us. It is a strange and gentle thing to sit at the center of a sphere of the visible, knowing that the sphere is not the edge of the world, but only the edge of our seeing. There is no harm in it, and no cause for unease. The galaxies beyond the horizon are turning quietly in their own light, indifferent to whether we can count them, exactly as the nearby ones are. We simply cannot reach them with our eyes, and so they rest outside the number, present but uncounted, real but unseen. And the boundary is not even fixed, for the expansion of the universe is carrying the most distant galaxies away from us, faster and faster, drawing some of them past the point from which their light can ever reach us again. The horizon is not only a limit we sit within, it is a limit that is closing, slowly sealing galaxies away beyond all future seeing. To understand the count fully, we have to understand that the visible universe is, in the long run, growing emptier, And to that quiet truth we turn next. The idea that to look far is to look back in time is so central that it rewards being turned over slowly. Light is quick, but it is not instant. It takes time to cross space, and across the gulfs between galaxies that time becomes immense. The light reaching us from a distant galaxy left it long ago and shows it not as it is now, but as it was when the light departed. We never see the distant universe in its present state. We see only its old light, a portrait of a past that finished unfolding before the image arrived. This turns the night sky into a kind of layered memory, and the layering is worth picturing. Nearby galaxies we see as they were, fairly recently. More distant ones we see as they were longer ago. The most distant we can see, we see as they were near the beginning, their light having traveled almost the whole age of the universe to reach us. A single view of the sky holds all these eras at once, near and recent, layered over far and ancient, the present and the distant past, gathered into one image of the dark. The horizon of the observable universe follows from this directly, and the sea horizon is the right way to feel it. The edge of what we can see is not a wall in space, but the limit of how far light has been able to travel in the age of the cosmos, just as the horizon at sea is not the edge of the ocean, but only the limit of sight from where you stand. The universe surely continues past that edge. There is simply more of it than light has yet had time to show us, and the boundary marks the reach of light, not the end of being. Folded into this is the quiet fact that some of the galaxies we count are, in the present, already gone. Many of the faint, distant galaxies we see in the early universe have, in the long ages since their light departed, merged together into larger galaxies. The galaxy we are counting may no longer exist as a separate thing. Its old light still arrives, carrying an image of something that has since become part of something else. We count it as we see it, young and separate, though its separate existence ended long ago. So the number that exists right now is smaller than the number we can see, and this subtlety sits at the center of the count. To see is to look into the past, and the past was more crowded with small galaxies than the present is. The 2 trillion blends the busy early cosmos, much of it since merged away, with the quieter present. It is a count across all of visible time, not a snapshot of this single instant, and the instant holds fewer separate galaxies than the long backward look suggests. There is no escaping this limit, and it is better received as a feature than a flaw. We are beings who see by light that takes time to travel, living in a universe of finite age, fixed at the center of a sphere of sight whose edge is set by how far light has come. Everything beyond that sphere is real and forever uncounted, not for lack of instruments, but because the light has not arrived. To give a number for the galaxies is always, quietly, to give a number for the galaxies that we can see. There is a further gentleness in realizing that the light from the most distant galaxies is not only old, but stretched and dimmed almost beyond recognition. By the time it reaches us, it has been pulled so far toward the red and spread so thin by the long crossing that gathering it at all is a delicate art. The faintest, farthest galaxies hang at the very limit of what can be detected, their ancient light arriving as the softest possible whisper, a glow that took nearly the age of the universe to cross the widening dark and find us. The universe is not static. Space itself is expanding, swelling steadily in every direction, carrying the galaxies apart from one another like markings on a slowly inflating surface. The galaxies are not flying through space so much as being carried by the growth of space between them. And this expansion is not holding steady or slowing. It is speeding up, driven by something we do not understand, which means the most distant galaxies are drifting away from us faster and faster as time goes on. This accelerating drift has a quiet and remarkable consequence. Because space between us and a distant galaxy is growing, and growing ever more quickly, the most distant galaxies are receding faster than the light they emit can close the gap. Their light, sent toward us, is carried outward by the swelling space faster than it can travel inward, and so it never arrives. There are galaxies we can see today by their old light whose new light will never reach us, because the space between us is now growing too fast for any fresh signal to cross. So there is a boundary, subtler than the edge of the observable universe, beyond which galaxies have effectively fallen silent to us. We still see their ancient light, the light that left long ago when the gap was smaller, but anything they emit now is lost to us forever, unable to outrun the expansion. They are visible and unreachable at once, present in our sky as a memory, while their present selves drift permanently beyond contact. The light is a postcard from a place we can no longer be sent word from. Over immense spans of time, more and more galaxies cross this boundary outward, slipping past the point of no return. One by one, across timescales far longer than the present age of the universe, the galaxies beyond our own small bound group will recede until their light stretches and dims and finally fades from view entirely. The accelerating expansion is slowly emptying our visible sky, drawing the distant galaxies away and out of sight, leaving behind a smaller and quieter cosmos than the one we see tonight. This means the count of galaxies we can see is not only uncertain, but, in the longest run, shrinking. Far in the future, an observer in our galaxy would find the sky beyond our local group nearly empty, the trillions of distant galaxies having receded past the horizon and faded away. They would see only the handful of galaxies bound closely to our own by gravity, with the rest of the universe gone dark and unreachable. The crowded cosmos we count tonight is, in a sense, a privilege of living when we do. There is a remarkable thought folded into this, and it is worth holding gently rather than mournfully. We happen to live at a time when the universe is still full of visible galaxies, when the light of trillions of them still reaches us, when the count is enormous and the sky is full. A civilization arising in the far future, after the long drift, might look out and reasonably conclude that the universe held only their own small group of galaxies, with no way to know that trillions more had once been visible and had since receded beyond all seeing. So our generous count, our 2 trillion, is partly a gift of our moment in cosmic history. The galaxies bound to us by gravity, our own and its near companions, will stay with us through the long ages, slowly merging into a single great galaxy. But the rest, the great distant multitude, is on its way out, carried off by the expansion, destined to fade from the sky of any far future watcher. The number is large now, and it will not always be. We are counting at a full moment in an emptying universe. There is no fear in this, and the telling should carry none. The galaxies are not being destroyed. They are simply drifting apart, each one carrying on in its own light, turning slowly, making and unmaking stars, entirely whole. It is only the connection between them and us that is being severed by the growth of space, only the possibility of seeing or reaching them. They go on being galaxies. They merely go on being galaxies somewhere we can no longer follow them with our eyes. And so the count is bounded twice over, once by the light that has not yet reached us, and once by the light that will never reach us again. Between these 2 horizons lies the sphere of the visible, the only region we can ever count, and even it is slowly thinning as galaxies slip away beyond the outer edge. The number of galaxies is hemmed in on every side by the simple facts of light, time, and the growth of space. It is real, and it is also, always, partial. What lies past these horizons we cannot count and may never know. But the universe gives us reason to think it is larger than our sphere of sight, perhaps far larger, perhaps without end. The galaxies we can see may be the smallest sampling of a whole beyond all reckoning. And that possibility, that our 2 trillion is a mere lit window onto something endless, is where the question finally opens all the way, and where its strange comfort lives. The accelerating expansion that carries galaxies beyond reach is worth approaching gently, because it sounds stranger than it feels once understood. Space itself is growing, swelling in every direction, and the galaxies are carried apart by that growth like markings on a surface being slowly stretched. They are not so much flying through space as being borne along by the expansion of the space between them. And the expansion is not steady, but quickening, so the most distant galaxies draw away from us, faster and faster as the ages pass. From this quickening comes a remarkable consequence, one worth holding slowly. Because the space between us and a far galaxy is growing, and growing ever faster, the most distant galaxies recede more quickly than the light they send can close the gap. Their light, aimed toward us, is carried outward by the swelling space faster than it can travel inward, and so it never arrives. There are galaxies we see today by their ancient light, whose present light will never reach us, the space between us now growing too fast for any new signal to cross. So beyond the edge of what we can currently see lies a subtler boundary, a point past which galaxies have fallen silent to us. We still see their old light, sent when the gap was smaller, but anything they emit now is lost to us forever, unable to outrun the expansion. They hang in our sky as a kind of memory, visible and unreachable at once, present as the image of a past, while their present selves drift permanently beyond any contact. The light is a postcard from a place we can no longer be sent word from. Across spans of time far longer than the present age of the universe, more and more galaxies cross this boundary outward and slip away. One by one, the galaxies beyond our own small bound group will recede until their light stretches and dims and finally fades from view entirely. The accelerating expansion is slowly emptying our visible sky, drawing the distant galaxies away and out of sight, leaving behind a smaller and quieter cosmos than the full one we are able to count tonight. The crowd is, very slowly, dispersing. This means a far future watcher would see a very different sky from ours, and the thought is a remarkable one to hold, without unease. Long from now, an observer in our galaxy would find the sky beyond our local group nearly empty, the trillions of distant galaxies having receded past the horizon and faded away. They would see only the handful of galaxies bound closely to our own by gravity, with the rest of the universe gone dark and unreachable, and no way to know that trillions more had once filled the night. And so our generous count is partly a gift of our moment in cosmic history, which is a quietly beautiful thing to realize. We live at a time when the universe is still full of visible galaxies, when the light of trillions still reaches us, when the sky is full and the count enormous. The galaxies bound to us will stay, slowly merging into one. The rest are on their way out, carried off by the growth of space. We are counting at a full moment in an emptying universe, and the fullness is a kind of fortune. By now it should be clear that the number of galaxies is not a fixed quantity waiting to be measured, like the height of a mountain. It is a figure that breathes and shifts, changing with what we count, when we count it, and how far we are able to see. To gather the threads of the night, it is worth naming the several ways in which the count refuses to hold still, each of them a quiet reason the question can never be cleanly closed. The count changes because galaxies merge. Over the long ages, smaller galaxies fall into larger ones, and many separate galaxies become one. The number of distinct galaxies in the universe has been slowly decreasing as these mergers proceed across cosmic time. So even within a fixed region, the count is not constant. It was higher in the crowded young universe, when small galaxies were many, and it grows lower as they gather together. The number depends on which chapter of cosmic history you ask about. The count changes because to see is to look across time. When we tally the galaxies in the observable universe, we are mixing eras, counting the crowded small galaxies of the distant past alongside the fewer larger galaxies of the nearby present. The figure is a mixture of all the moments we can see at once. There is no single instant being counted, and so no single clean number, only a sum spread across the whole visible history of the cosmos. The count changes because better instruments only ever find more. Every advance in our ability to gather faint light has revealed galaxies that were previously invisible, and the total has only ever climbed. The number has never once been revised downward by improved technology. There is no reason to think the present figure is final, and good reason to think that sharper future instruments will find still fainter and more distant galaxies, lifting the count again, as every advance has lifted it before. The count changes because the definition has a soft, lower edge. At the faint bottom of the scale, where small galaxies blur into star clusters, the total depends on where we choose to draw the line. Shift the boundary slightly, and the number leaps or falls because faint small objects so greatly outnumber bright large ones. Part of the count is a decision rather than a measurement, a choice about what to call a galaxy, made across a continuum that nature left smooth and unbroken. And the count is bounded by horizons we cannot pass. We can only tally the galaxies whose light has reached us, and the accelerating expansion is carrying the most distant ones away beyond all future seeing. Whatever lies past the edge of the observable universe is uncounted, and, in much of it, uncountable. Our best and largest figure is a count of the visible sphere alone, a lit room within a house whose full size we do not know and may never learn. How large is that house? We do not know, and the honest answers range from considerably larger than the visible part to immeasurably larger, with some frameworks allowing the universe to be infinite in extent. If it is infinite, then the number of galaxies is, in all likelihood, infinite too, and every finite count we make, however staggering, is a vanishing fraction of an endless whole. 2 trillion would then be not the number of galaxies, but merely the number we are placed to see, a tiny sampling of a multitude without bound. So the right image for the count is not a fixed inventory, but a slow tide, tira-ah. The number rises as we look deeper, falls as galaxies merge, drifts as we argue over the faint edge, and stands always within horizons that hide far more than they reveal. There is no final ledger to be closed, no last galaxy to be tallied, no moment when the counting will be done. The question stays open, not because we have failed to answer it, but because the answer is, by its nature, unfinished. This could be told as a frustration, but it is truer and kinder to tell it as a feature of the thing. The number of galaxies is large beyond grasping, uncertain at its faint edge, shifting across time, and bounded by horizons we cannot cross. Every one of those qualities is a way the universe exceeds our counting. The cosmos is simply larger and fuller and more fluid than any single figure could hold, and the unsettled number is the honest shadow of that bigness. And so we come to rest not on a number, but on a shape, the shape of a question that opens outward without end. There are at least 2 trillion galaxies within reach of our sight, and beyond them, quietly, an unknown and possibly endless multitude more. That is as close to an answer as the universe permits, and it is enough. What remains is not to pin the number down, but to sit with its bigness, and to find in that bigness, as we now will, a strange and genuine peace. To gather the night's threads, it helps to name plainly the several ways the count refuses to settle. Each one a quiet reason the question stays open. The first is merging. Over the long ages, smaller galaxies fall into larger ones, and many separate galaxies become one. The number of distinct galaxies has been slowly decreasing as these mergers proceed. Even within a fixed region, the count is not constant. It was higher in the crowded young universe, and grows lower as the galaxies gather together over time. The second is that to see is to look across time. When we tally the galaxies in the observable universe, we mix eras, counting the crowded small galaxies of the distant past, alongside the fewer larger galaxies of the present. The figure is a mixture of every moment we can see at once. There is no single instant being counted, and so no single clean number, only a sum, spread across the whole visible history of the cosmos, weighted toward the busier past that fills so much of our backward view. The third is that better instruments only ever find more. Every advance in gathering faint light has revealed galaxies previously invisible, and the total has only climbed. The number has never once been revised downward by improved technology. There is no reason to think the present figure is final, and good reason to expect that sharper future instruments will find still fainter and more distant galaxies, lifting the count again, as every advance has lifted it before. The number grows with our seeing, and our seeing is not finished. The fourth is the soft, lower edge of the definition. Where small galaxies blur into star clusters, the total depends on where we draw the line, and because faint small objects so greatly outnumber bright ones, the figure leaps or falls with a slight shift of the boundary. Part of the count is a decision rather than a measurement, a choice about what to call a galaxy, made across a smooth continuum that nature left unbroken. The number carries a little of our choosing folded inside it. And the fifth is the horizons we cannot pass. We can only count the galaxies whose light has reached us, and the accelerating expansion is carrying the most distant ones beyond all future seeing. Whatever lies past the edge of the observable universe is uncounted, and, in much of it, uncountable. How large the whole universe is, we do not know, and honest answers range from considerably larger than the visible part to immeasurably larger, with some frameworks allowing it to be infinite and the galaxies with it. So the truest image for the count is not a fixed inventory, but a slow tide, and there is peace in seeing it that way. The number rises as we look deeper, falls as galaxies merge, drifts as we argue over the faint edge, and stands always within horizons that hide far more than they reveal. There is no final ledger to be closed, no last galaxy to be tallied, no moment when the counting will be done. The question stays open not because we have failed, but because openness is its honest and permanent nature. A number like 2 trillion is past the reach of the mind, and there is no use pretending otherwise. We cannot truly picture 1,000 galaxies, let alone 1,000 billion of them, and the figure, however carefully arrived at, lands on us as a word rather than an image. But there are quiet handholds, small ways to feel the scale without straining for it, and at the end of the night, it is worth resting in a few of them, slowly, with no need to grasp the whole. Imagine trying to greet the galaxies one by one, naming a single galaxy every second, without ever stopping to sleep or rest. At that steady pace, the counting of 2 trillion galaxies would not take a year, or 1,000 years, or 1,000,000. It would outlast a human life many thousands of times over and run on far past the present age of the universe itself. You could count for the entire history of the cosmos and not finish. The number is not large in the way a crowd is large. It is large in the way time is large. Now consider that each of those trillions of galaxies holds, on average, many billions of stars. Multiply the galaxies by the stars within them, and the number of stars in the visible universe becomes a figure with more than 20 digits, a number so great that it comfortably exceeds the grains of sand on every beach and in every desert on all of the earth. For every grain of sand on every shore in the world, there are many stars in the sky. The old comparison is not poetry. It is a careful undercount. And our own galaxy, with its hundreds of billions of stars, its sweeping arms and its quiet companions, is one ordinary entry in that uncountable ledger. It is neither the largest galaxy nor the smallest, neither rare nor remarkable, simply one island of light among trillions, turning slowly in its own corner of the dark. Our sun is one star within that one galaxy, and our world is one small companion of that one star. We are a single grain on a single shore of an ocean, without a measured end. There is a way of receiving this that brings not smallness, but rest. And it is the note to settle on tonight. Every one of those trillions of galaxies has been turning for billions of years, making and unmaking stars, entirely indifferent to whether anyone was counting them. The number was always there, complete, long before we learned to read it, and it will remain long after. Nothing about the universe depends on our tally. The galaxies do not need to be counted in order to go on being what they are. And so the impossibility of a final answer turns out to be a gentle thing rather than a hard one. We will never know how many galaxies there are, not really, because the question reaches past the edge of everything we are allowed to see. But that not knowing is not a wound. It is simply the size of the universe making itself felt, a reminder that the cosmos is larger than our counting and was never ours to fully measure. There is a quiet ease in a number that does not need to be finished. Let the bigness of it settle over you, then, the way a wide night sky settles over a quiet field. At least 2 trillion galaxies within sight, and beyond them, softly, more than seeing will ever allow. Each one a wheel of light, turning slowly in the dark, full of stars and worlds we will never name. They were turning long before anyone thought to count them, and they will be turning long after this night is forgotten, patient and unhurried, and entirely at peace. There is nothing here you need to hold, or solve, or carry into sleep. The galaxies will keep their number, whether or not you remember it. The count will go on rising, and the horizons will go on hiding most of it, and none of that asks anything of you tonight. You are one small, warm, living thing beneath a sky of trillions, and that is not a loneliness. It is a kind of belonging, a place within something great and quiet that has held you all along. So let the question rest where it began, open and unanswered, larger than any number. How many galaxies are there, really? 2 trillion that we can see, and beyond them, more than the universe will ever let us count. Let that be enough. Let the not knowing be soft. Let the great slow wheels of light turn on in the dark, without you having to follow them any further tonight. It is worth lingering on the comparison to grains of sand, because it is so often said and so rarely felt. The number of stars in the visible universe, all those trillions of galaxies multiplied by the billions of stars each holds, comfortably exceeds the count of every grain of sand on every beach and in every desert on Earth. Picture a single handful of sand, the uncountable grains in your palm, and then every shore and dune in the world, and know that the stars outnumber them all. And the galaxies are not the stars. They are the great cities the stars live in. There is a way of feeling small under this that turns, if you let it, into something more like rest. We are one world, circling one ordinary star, in one unremarkable galaxy, among at least 2 trillion we can see, and an unknown host beyond. That could be a vertigo, but it need not be. It can instead be a settling, a sense of being held within something so large and so old that our worries shrink to their proper size, and the night grows wide and quiet around us. The galaxies ask nothing of us, and there is a quiet comfort in that. They were turning long before anyone counted them, and will turn long after, indifferent to whether we ever name them or number them correctly. The count is ours, a small human reaching towards something that does not need our reach. The universe is complete without our tally. We are free then to wonder at it without the burden of finishing it, to look up and feel as its size without any duty to measure it down. So let the not knowing be soft tonight, rather than sharp. We will never know how many galaxies there are, not truly, because the question runs past the edge of everything we are allowed to see. But the not knowing is only the size of the universe making itself felt, the gentle pressure of a cosmos larger than our counting. There is ease in a number that does not need to be finished, and rest in a question that is content to stay open, turning slowly, like the galaxies themselves. Let the great slow wheels of light turn on in the dark, then, without your needing to follow them any further. At least 2 trillion within sight, and beyond them more than seeing will ever allow, each one full of stars and worlds you will never name, each one entirely at peace in its own far corner of the night. You have wandered out to the edge of the count and found, instead of an answer, a quiet that is large enough to lie down in. That is enough. That was always enough. And so we leave the number where it belongs, open and unfinished and far larger than anyone can hold. They were turning in the dark long before we counted, and they will be turning there long after. Let your breathing slow. Let your thoughts drift out past the last galaxy and grow quiet. Let the great, uncounted sky be, for tonight, nothing but a kind of peace. Sleep well, and good night.